In this demonstration, I'll show you how to multiply any two or more radicals. I have several examples for you, and as we proceed, they will get more difficult. In this case, we are asked to multiply the square root of x times the square root of 2y. One very important thing to keep in mind is that if the indices are the same, in this case, the index here is 2 and the index here is 2, even though it's not written. So going back to that idea, if the indices are the same, you can multiply the two radicands, x times 2y. So in this case, x times 2y is 2xy, and that's your final answer. Let's move on to the next example. Here, the indices 3 and 3 are also the same. So what we have to do before we multiply the radicands, this and this, is we have to multiply 5 and 2, which is equal to 10. And we will keep the index of 3 the same, and we will house the two radicands underneath the radical. So in this case, we have 3a times 4b is equal to 12ab. There you have it. Two radicals combined. Let's continue. In this case, we are asked to multiply three radicals at the same time. So we'll start off with the coefficients 2, 5, and 3, which is equal to 30. And then we will multiply m, n, and mn together. Now notice that the radicals all have an index of 2. They're all square roots. That being said, they can all be housed underneath one radical. M times n times mn is equal to m squared n squared. Now, before you conclude as this being the final answer, keep in mind that m squared and n squared are both perfect squares. So you end up with 30, the square root of m squared is m, and the square root of n squared is n, and that's it. Let's continue. Now the next two examples are a little more difficult. And they're a little more difficult because this time we're faced with two radicals with different indices. This has an index of 2, this has an index of 4. In order to combine these, I've written a note here that if the indices are different, first change the radical into fractional exponents, and then try to make the denominators the same, then finally returning to radical form. So this is what I'm referring to. We all know that the square root of a is the same thing as saying a to the power of half. And similarly, the fourth root of b is the same as saying b to the power of 1 over 4. So according to this note here, it says first change the radical into fractional exponents, which we just did, and then try to make the denominators the same. So our next goal is to make this and this the same. So the 2 and the 4. So how can I make the 2 into a 4? Well, we can multiply the 2 by 2, but if you do it to the bottom, you also do it to the top. So you end up with a to the power of 2 over 4 and b to the power of 1 over 4. That being said, we can now convert these back, according to this, to their radical form. So let's do that. Fourth root of a to the power of 2 times the fourth root of b. Now the reason this is more ideal than what we had originally is because now the indices are the same. And as with the other examples above, if the indices is the same, you can combine the radicands. The final answer becomes the fourth root of a to the power of 2 times b. Let's try another one. In this case, we have a radical multiplied to an algebraic expression that's a binomial. So in this case, you would have to expand. Let's start off by multiplying this radical with this radical. Notice how the index is the same. So we end up with 100 x to the power of 2 underneath one radical. 50 times 2 is 100. X times x is x squared. And similarly, this radical times this radical is equal to 50 x squared y square rooted. Now don't be tempted to conclude that this is the answer. Both the x and the 100 are perfect squares. And as such, the answer becomes 10x. And in this case, 50 is not a perfect square, but it can be broken down into a perfect square as 25 and 2. And let's just go one step at a time so we don't get confused. All I've done is broken down that 50 into 25 and 2. And I end up with 10x minus the square root of 25, the square root of x squared. 2 and y are not perfect squares, so you leave them. And many of you will conclude that that's the answer, and if you rationalize, you're correct. It is. Some people might even want to factor out the 5x to end up with the following, but it's not important because you've already accomplished your goal of multiplying the radicals. So this answer and this answer will suffice. If you have any more questions related to this video, please comment below, and if you found it helpful in support of our page, please like this video. If you have any more questions related to this, use our website at biology-forums.com. It is a free homework service offered to students. See you soon.